Corn School is brought to you by BASF and Pride Seeds.
We're here with Dr. Dave Hooker here at Ridgetown College, and we're going to talk a little bit about drought and the impact it has on corn today. And Dave, it's been a dry one, and people are interested in how much potential they've got left in their crop. And I noticed you're wearing a Maple Leafs hat.
Yeah.
You believe in potential, no doubt.
Yeah, potential, and I'm an optimist, obviously.
Well, big year coming this year. Let's talk about this corn crop. Now, tell us about when drought has impact. When does it impact the crop?
And so corn undergoes significant periods of different stress tolerances. And so the most critical period for that stress to occur that really impacts the yield is right around a 2-week bracket that brackets around silking time. That is the most stressful critical period.
So that's when it's setting the number of rows, number of kernels, right?
Yeah, so the row number, the number of rows around the kernel, around the cob itself is set around the V6 time. And then the length of those ears are set about 2 weeks before silking time or so. So during that time, about 2 weeks before silking time, that's when the potential really is set. So that's when the kernel number, total kernel number per acre per se, would be set in the crop. And so what happens during that 2-week period around silking, that really determines the final kernel number, which is a big difference than the potential kernel number. So this corn around us, it underwent a severe drought impact to this corn crop in the vegetative phase itself. And when a corn crop experiences stress during the vegetative phase, it will slow down in development. And so you can really see this corn right now. The silks are nice and green, and a full season hybrid, it's the first week of August, and the corn plants are just starting to pollinate, or the silks just came out of this corn.
Yeah. Now you brought actually this hybrid, the same hybrid, not so far away.
Yep.
In a normal field that got some good moisture. There's the difference, eh?
That's right. So same maturity hybrid, planted about the same, maybe a couple days apart in the spring, but you can see how advanced this plant is. So it's fertilized, it's in the blister stage, and the corn around us is still in just the corn. The ovules are still waiting to be fertilized in much of this corn around us. And of course the silks came out later in the stressed corn around us, and there's not much pollen around, so there's an excellent chance that most of this corn, most of these poor silks will not be pollinated, and the corn will not be fertilized.
So let's look at what type of yield difference now are we looking at between this one, obviously, which has gotten good moisture, good pollination, and our droughted corn. I mean, and how can we assess it as we're doing our field walks?
Yeah, so we can assess yield potential by a number of ways, and one of them is the kernel count method. And so what you can do is just rip off a ear like this, and then count the number of kernels. So count the number of rows, and then count the number of kernels per row, and then multiply those together. And so that will give you the number of kernels per ear. And then if you have, let's say, 30,000 plants per acre, multiply that by 30,000, and there's about 80,000 kernels per bushel. And so just divide that number by 80,000, and that will determine the potential, the grain yield potential. And so lots of things can happen to that grain yield potential. If these corn ears and the stress corn do not get fertilized at potential, the actual yield would be very much lower than the potential.
Yeah. So what type of impact are you guessing? If you're looking at this,
yeah, so this one, if we have, if we do the kernel count and then divide by 80,000, we're looking at a 250 bushel yield potential with this corn crop that would look like this. Compared to the corn crop around us, maybe there's a 70 bushel yield potential with this kind of drought impact.
Well, amazing difference. Well, Dave, thanks so much for this. We'll see what the potential is in this plant, and we'll see what happens with the leaves.
Thanks, Bernard.
Okay.